Guys, in this video I'm gonna show you how to solve count of subset sum given a set of positive numbers. Find the total number of subsets whose sum is equal to a given number s. Right. So for example, this given input 1 1 2 3 positive numbers, right? Find the total numbers of subsets whose sum is equal to 4, right? So the answer is 3. There are total of 3 subsets whose sum is 4, which is 1 1 2, 1 3, and 1 3. This is duplicated, as you can see, because we have 2 1, right? So even in this case, we consider as 2 different set, right? With this one come from here and this one come from here. Note that we can have 2 similar sets, right? Because we have 2 1 in our input. Okay, that is it. In this video I'm going to show you how to solve in a brute force approach, right? Generally, for a dynamic programming problem, we're gonna have like uh, two approach in general, which is top down and bottom up. Right? Actually, later we can refactor uh, this brute force approach uh, into a top down approach using um, caching, right? So that we can optimize the time complexity. Uh, for now, let's start simple first, right? Okay, we have a count subset sum functions by taking a random number and the target. Okay, so for brute force approach, let's try uh, to list out uh, possible all these possible subset that we can list out all the subsets that we can have, right? In order to have a consistent way of generating subsets, we will start with every number, right? We iterate to not iterate, but we wanna consider every number, right? 1 1. Okay, 2 3. Okay, so for each number we will have two choice, right? Which is we take number, take for example, you take one, skip one, right? Okay, you have two choice. If we go with this choice, then when consider the next number, right? Which is again another one, right? So again, two choice, one and take one and skip one. And even if we go with this choice, which is skip one, skip the first one, we again have two choices: take one or skip one. Okay, so all the possible choice has been listed out here. Next, we consider two. Okay. So for each number from the last level, let's say, um, we have two choice. For one, we have two choice, which is take two and skip two. Here also, take two, skip two, and so on, right? So, um, what it means is that uh, for each, let's go with this path. I call it path, right? This path represents a possible subset, right? Which is 1, 1, 2, right? And another subset would be 1, skip one here, 2, 1, skip one here, skip 2 here, right? So by doing so, we will eventually having all the possible subset. No, here two choice. From this one, we have two choice: take two and skip two. From this choice, we have two choice again: take two or skip two. Okay. Again, all the choices has been selected out. Next, number three. So from two here, we have two choices: take three or skip three. And so on and so forth. Right. Um, so as you can see, we're having uh, kind of a tree, right? And a binary tree, right? Because from each node, we branch out into uh, two choices. Just like, and yeah, wanna use a depth first search with recursions um, to 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 how to say uh, to um, to list out all the possible subsets, right? So whenever we don't have to go all the way to three here, but uh, if a current, when I keep track of the current sum, right? If the current sum is equal to the target, we can stop right there and probably increment our final count, right? The subset will sum up to target, or if it is let's say uh, if it is greater than this as when we can exit the current part right away. We don't have to go all the way down the leaf node, right? So let's say, as you can see, at each level, we consider one number from our input. So in order to do so, I will need to keep track of a uh, num index, right? Num index initially is 0, right? If we don't pass it in, and we can increment this one as we go down the tree. We go down the tree simply call by calling a recursive function, right? Passing in the uh, the new arguments. So here, in order to go to the next level, consider the next number. For example, the current number index is 0 at first. I will call it with num index plus 1 for the next level. By the way, let's want to see later num index. What else we need to keep track here? We need to keep track of the current sum as well. Current sum initially is 0. Okay. Mm, what else? Okay. The current sum and the final count. Uh, is it good enough? Um, because this one, I wanna, I wanna, I wanna have its state is uh, is the same for every recursive call. So I don't want it to be a just a number. It's gonna should be a an object instead, right? So final, let's say final as a count is the object with key count and values is 0. Okay, gonna start our recursive functions. We should have a base case um, and recursive. Okay. Oh, for each recursive functions, I wanna visit one. Uh, I'm gonna consider one number from our input, right? Recursive. Consider no. Wait a minute. By the way, for each these functions, I'm gonna consider nums at num index, right? I'm gonna actually I can here. So when I consider this number, I have two choice. Uh, choice one, which is take this number. Choice two, skip this number. Okay. So what is the base case here? So I will stop when if the current sum is equal to the target. I want to stop here. I want to increase the final count. Final count plus plus. Okay, and I want to return another case when I want to stop, which is the current sum or if current sum is greater than the target. uh, I want to return also. Uh, okay, yeah, if it is current equals target, increase the count and return. If the current is greater than target, you can stop recursions, right? So let's go to recursive part. We consider this number. We have two choice. Choice one will be take this number. It means well, the same here. Uh, Num's target. Okay, I will call this function recursively with new arguments. Number index will be the next number that we consider. Which is of index num index plus 1. The current sum will be a new sum because we decide to take this number, so it will be current sum plus nums at num index. Final will be the same. Okay. Uh, we don't need to backtrack here because each recursive call will maintain its own state without modifying the state of with a messing up the state of other recursive call because here is just passing number, right? Number is primitive value in JavaScript. So count subset sum, the second choice, passing nums, passing target. Num index will be the same here, but the current sum, because I decided to skip this number, so it will be the same, right? The current sum will be the same, and the final will be just pass around the same for every recursive call. Okay, so finally I will return the final count. Okay, that is it. I think let's try to run the test. Just 15. Fine. Okay. Whoops. Oh, kind of we run into a recursive infinite recursions, I guess. Oh, we probably want to start when the index num index is equal to is out of range, right? Nums dot length, right? This is when we want to sort also. Here I can move this return into here, right? So if it is equal here, I can implement and I can return here, right? Okay, run it again. Okay, it works. So that is it for count a subset sum using a brute force approach, right? Uh, in another video, I'm gonna show you how to optimize it uh, with cachings and also um, take another approach, which is bottom up, right? With two-dimensional table. So that is it for this video. Thanks for watching. See you in the next one.